We'll start off the build by gluing the wing sections together. Add a heavy amount of glue to the center section on both sides. Then, with a good amount of pressure, press that center section into each wing. Move them around a good bit to make sure both sides are coated with a heavy amount of glue. You will note that the wings are beveled at the back. Be sure that the beveled edges line up. Now you might find that the glue didn't coat perfectly. In that case, just wipe it down with your finger. Then leave these sections to dry for a few minutes. After approximately 10 minutes, the glue should be dry and the wings can be pressed together. Line up the wings to the center section and then with a good amount of pressure, press them together hard. Flip the wing over and make sure that both the top and the bottom are lined up evenly. I recommend letting the wing dry overnight before moving on to the next step. Line your spars up approximately 1.5 to 2 inches from the leading edge of the wing. And then take a pair of wire cutters or diagonals and cut your spars. You will need to make 4 spars of this length. Using a straight edge and a good sharp knife, cut approximately 1/8 of an inch deep into the foam. Repeat this for the other side, trying to make sure that it lines up approximately where the spar does on the other side. Take your glue and using the tip as a wedge, embed a good amount of glue into the slit you have just cut. The glue should squeeze out as the foam comes back together. Once it's sufficiently filled, then insert your spar. I recommend bending the spar and pushing it down in. Do not slide your fingers down the spar, or you will end up with splinters in your finger and an itch you'll never forget. Repeat this same procedure for the other side. Again, be sure you add a good amount of glue as these spars truly stiffen the wing up quite a bit. I know they seem flimsy, but once this thing is built, it's going to feel rock solid. Flip the wing over and repeat the procedure on the back side. Do your best to line up the slit with the spar that's on the other side of the wing. The idea is that these spars will create an I-beam and therefore stiffen the wing greatly, so it's best to be sure that they line up. To install the main stress spar. I recommend installing this approximately 3 inches from the back of the aircraft. Again, use a straight edge to cut a line approximately 1/8 inch deep, then use a good amount of glue to fill that slot. You're going to have to cut the spar to this length before installing it, of course. And just as before, you'll repeat this procedure for the other side. Laminating greatly increases the airplane's speed and durability. Lay the laminate with the glossy side up over top of the airframe. Then, using an iron with a good amount of pressure, iron it over the entire airplane, starting with the center and working your way to the edge. Once you've got the airplane fully stuck down on the top side, then you may flip the aircraft over and do the same thing to the bottom. Be sure to pull the laminate tight as you do this procedure. If you don't have a covering iron like I'm using, a clothing iron works just fine. The temperature setting should be approximately 180 degrees Fahrenheit, or whatever temperature that seems to work well for you. Again, be sure to pull the laminate tight, and when you fold over like I'm doing, be sure you cut the corners with a knife and then adhere them to themselves. Pulling it tight ensures there aren't any wrinkles. And don't worry about parts that aren't covered. Laminate sticks very well to itself, so you can add patches along and you'll never see a seam. The best way to attach the elevons to the airplane is to laminate them in place. Cut a section of laminate just a bit wider than the elevon, then adhere it to the main frame. Then, pinching the elevon tight to the airframe, laminate that side down. From there, flip up the elevon section and adhere the bottom side. Again, use a good amount of pressure as you do this. Then, flip the aircraft over and adhere the bottom side to the bottom part of the airframe. Do not forget to get the inseam. Now we'll install the servos. Measure approximately 2/3 of the way down the elevon and make a mark. Then, at approximately 2.5 to 3 inches back, make another mark. This will be the corner of your servo. Then, using your servo as a jig, trace the outline of the bottom of the servo. Then, cut the inside of that outline out with a knife. I'm using a custom modified soldering gun with a piece of music wire to cut out my servo chamber, but you can simply cut it out with a knife and pry out the foam with a pair of pliers. It really doesn't matter. Then test fit your servo. If it fits, go ahead and glue it in. The next step is to try to fit your servo horn. I simply pushed the screws in the servo horn straight through the balsa wood and cut the back, but it's probably better to use a sharp object such as a drill bit or something similar. Press the screws all the way through the balsa wood, and then, using the plate on the back side, screw the screws in good and tight so that it locks the control horn in place. Once set, now you'll make your control arms. Your control arms are composed of just 2 clevises and a piece of threaded rod. You'll need to trim your threaded rod so that the length is exactly right. I'm using a pair of diagonals to cut the threaded rod, but a pair of pliers with a cutter works just fine. Adjust the control arms so that the elevon is deflected just slightly upward while the servo is centered. Next step is to install the mid-wing stabilizers. Measure between 6 and 8 inches away from the center fuselage. I'm using 7 inches as it splits the difference. Now, using a straight edge, make a line between the 2 marks you've just made. You'll want to go all the way to the back, almost an inch away from the elevon. Again, repeat this procedure on the bottom side, being sure you use the exact same measurement, as this length is critical because the mid-wing stabilizer needs to line up. Again, use a straight edge and make a line from about an inch away from your elevon all the way around the wingtip. Now check to be sure that your line actually lines up with the other side. If it does, then you're going to take your knife and make an impression about 1/4 of an inch deep or 1/4 of an inch deep into the foam. The mid-wing stabilizer embeds in this. It's okay to cut a little bit deep as you're going to fill this with glue and it will solidify itself. Cut this line on both the top and the bottom side. Dry fit the mid-wing stabilizer to the slot you just made. Now take a pen or a marker and mark out where the spar crosses under the mid-wing stabilizer. Then, using a pair of diagonals or scissors or other device that will cut, make a V-notch at these locations where you just marked. Again, repeat this procedure on the bottom side. Once the notches are cut out of the mid-wing stabilizer, embed a good amount of glue, just like you did with the spars, and slide the mid-wing stabilizer in place. It's a good idea to add a little bit of extra glue to the front side, as these tend to attract grass in hard landings. The winglets simply get glued on just as every other component. Coat the edge of the wing in a heavy amount of glue and then rub it in so it's smooth with your finger. Then take the winglet and attach it to the side of the wing. Now, I recommend letting it stick out about 1/8 of an inch, as this will catch a little bit of extra air and give you a little bit of extra stability when flying. To get the plane to balance, you're going to need a fairly large battery, which I recommend mounting horizontally in the front of the airplane. Use the battery as a template and cut out the foam where the battery ends up. I'm using an X-Acto knife, but you can also use the tool I used to cut the holes for the servo if you like. Simply trace along your lines and then slide the knife underneath the former to cut out the bottom, and then pull it out with a pair of pliers. Repeat this for both sides. You're going to need a fairly large battery for this airplane. I recommend at least a 3-cell 4000 milliamp hour battery, or for you guys that like to run 4-cell, a 4-cell 3300 seems to be about the right battery to get this thing to balance with a nice big powerful racing motor. The center of gravity on this aircraft is 8 inches from the nose. Now you'll see that I cut a notch and slid the motor forward. This was to achieve a better center of gravity. It's much easier to move the motor forward than it is to add weight to the nose, as dead weight does no good in a race. This photo shows how I laid out the electronics. You'll see that the video transmitter is off to the side, and then I moved my control antenna out to the other side to gain some extra separation. You'll also see there's a flight controller in there. I'm using a Naze 32 to stabilize the aircraft, as in a race it seems to work well with multi-rotors, and I figure it will perform similarly well with a flying wing. The battery bay is large enough for flight controllers, autopilots, and just about anything else you want to stuff in the aircraft. So I encourage you to experiment and see what works best for you. I might be crazy, and fly this like you stole it.